I've been in networking for over a decade and decided to make some content to try to help others understand this industry. Let's talk today about one of the most fundamental parts of network communication, and that is the Open Systems Interconnection Model, or the OSI model. It's a framework for understanding how communication works on the network. It has distinct layers, and as long as the sender and receiver and the transmitting devices between anything that is functioning at these specific layers, as long as they communicate the protocol correctly, then traffic flows. So we'll look at this a little bit more in a moment here with some examples. But the seven layers, they kind of go from bottom to top, where layer one is at the bottom, layer seven is at the top. From the bottom, the first layer is the physical layer, and then it's the data link, then network, transport, session, presentation, and application. A helpful way to remember this, and this is what I learned many years ago when I first got into networking, a little mnemonic that stuck in my head. So hopefully it sticks in your head and helps you remember. But from bottom to top, it's please do not throw sausage pizza away. Kind of silly, but it works. I still remember that many years later. So the interesting thing about this, so when a device is sending a message, it starts at layer 7 and sends all the way down the stack to layer 1. And then when a device is receiving that message, it receives it at layer 1 and then processes back up the stack to layer 7. So we're going to kind of look at each layer specifically, and then I'll tell you which ones are really important for networking. So the application layer, this was confusing to me when I first got into this industry because I thought it meant the actual programs themselves, but it's not. The application layer is actually what provides the network services to the applications and the programs that you're using. The presentation layer handles data formatting and encryption. The session layer, it manages the connection between the applications. And the transport layer, it ensures the reliable and efficient delivery of the data, whereas the network layer has logical addressing and routing of the data. And the data link layer, it's physical addressing and error detection. And then the physical layer is the transmission of the raw bits. And we'll look at that a little bit more too. So from my experience, for networking, we really focus on layers 1 through 4. 5, 6, and 7 are important to have a general knowledge of, and if you're getting into cybersecurity, those really become more important. But for most network communication, 1 through 4 is really where things matter the most. So we're going to do a little bit of a deep dive into this. So the transport layer, this is important because you can't just send like an entire gig file all at once across the internet and then just have it as one bundled piece of information. So the transport layer, it actually chops up those large files. So it's responsible for segmenting the data into what we will call segments. And it kind of chops them up. And there's two main protocols that help with this. There's TCP, which is the Transport Control Protocol, and then there's UDP, which is User Datagram Protocol. So the difference between these is that TCP actually builds a connection between sender and receiver, and so it's considered a connection-oriented protocol. Where UDP, it's kind of best effort. It sends the traffic. If it gets there, great. If not, it's not trying to retransmit or do anything like that. If it missed it, well, you missed it. Too bad. And there are uses for these because, like, if you're trying to transfer a file, you want to make sure that you get all of the information in that file. So that's where a connection-oriented protocol is really helpful. On the other hand, if you're just on a video conference call, if there's a couple packets that get missed, it's not a big deal. You really wouldn't want the network to be bogged down retransmitting traffic of here's what was said or here's a frame that used to be there but now it's not, because you're past it. You're now on to the new point in time. So what happened before, it's not as important. So we wouldn't really want to get bogged down with retransmitting. So UDP is really good for those types of communications, video conference. It's a good example of that. So when this large message is being sent, like I said, the transport layer is responsible for chunking that up into smaller pieces of information that can be transmitted. So each one of them gets a header that's assigned to it. And when that header is put on, then it's called a segment. So if UDP is being used for the protocol, then the headers are very small because there's not a whole lot of information you have to put in the header itself. You're just trying to send it to its destination and hope it gets there. On the other hand, if it's TCP, it's a much larger header because there's more information that we want to get in there. And one of the really important fields inside the TCP header is the sequence number. So every segment gets numerically ordered for a sequence. And then the important part about that is when you have that sequence number, not only can the receiver say, hey, I received sequence 1 and 3, I missed 2, can you resend sequence 2 to me? The other part of it is that when it's receiving that, it can also reconstruct all of the data back into the original structure because it knows what order to put each one of those little pieces in. So that sequence number is very important. So moving on to the network layer. So this is responsible for the logical addressing, which we would call IP addresses, and we usually use IPv4 or IPv6 for this. When that segment is done at layer 4 and it comes down to layer 3, what we're left with is there's this segment that's there, and now the network layer has to add its own headers to that segment, and it needs to have in its header the source and destination IP address. So once we get that header on it, and there's more fields that go into it, but those are the important ones we want to talk about just for basic understanding is the source IP and the destination IP for this segment. Once that header is added to it, now we call it a packet. All right. The packet then gets handed down to layer 2, which is the data link layer. Once this is at the data link layer, it's responsible for the physical addressing. The data link layer adds its own header to the packet, and at this point it's going to have, depending what protocol you're using at layer 2. So a legacy protocol that's not really used anymore is called frame relay, and that protocol has its own type of addressing that it would put on the header. We typically use Ethernet now, so the addressing that we use for physical addressing is MAC address, machine access code address. So at the layer 2 header is going to have the source MAC address put in there as well as the destination MAC address. At this point, it's no longer a packet. Now we call this a frame. Layer 2 is done with it now that it's turned it into a frame, and it hands it down to layer 1. Now we're at the physical layer. At this point, this is where all that information gets converted into whatever the transmission medium is. So if we're using a copper cable, then this frame gets converted into electrical pulses representing ones and zeros and goes across the wire. If we're using an optical cable, for example, then now they're pulses of light that represent the zeros and ones and get transmitted across the fiber optic cable. So one of the really ingenious things about this design is that you can replace the protocols that are working at any one of these layers and the communication still works. So at layer 4, the communications type could be TCP or UDP. As long as the other side knows what it's using, then your communication will still work. You don't have to replace your IP addressing or your MAC addresses or even your cabling just because you change out what protocol you're using at layer 4. Also, if you decide you want to switch from copper cabling to fiber optic cabling, you don't have to re-IP everything because that's a separate layer of the OSI model and it's independent. It still requires that you have a physical layer that functions, but it doesn't have to, your IP addressing isn't dependent on what protocol you use at the physical layer.